An experiment is where you're actually saying, like, this is my control, like I'm not doing anything to a certain group, and then I am going to experiment on the other group and see how my results compare. So that could be like if you wanted to know if eating vegetables affects your health, you could give your dad a diet without any changes, and then give your mom a diet where she eats 3 times the number of vegetables she usually eats, and see how her health changes and if that's any comparison to your dad. Of course, you'd want more people than just, one person for the control and one person for the experiment. But that's an example of an experiment. All right. So we have our empirical rule for number 33. We have a mean of 7.5 pounds. So 7.5 goes right in the middle. And then a standard deviation of 1.2 pounds. So I need to add 1.2 to get the next standard deviation, which would give me 8.7. I add another 1.2 to give me 9.9. And then I add another 1.2 to give me 11.1. And then I do the same thing on the other side, but now I subtract. So 7.5 minus 1.2 would be 6.3. Subtract another 1.2, which would be 5.1. Subtract another 1.2, which would be 3.9. And that gives me my standard bell curve, something like that. Could be a little bit better drawn, but it's hard to do on the screen, so I apologize. And then this is broken into our standard deviation sections. So we have 68% of the data between our first standard deviation above and below the mean. And then we have 95% of the data between our second standard deviation from the mean. And then we have 99.7% of the data between our third standard deviations from the mean. So when it asks what percent of babies weigh between 6.3 and 8.7 pounds, that's within the first standard deviations. So that would be 68% of the babies, or 68% of the data is between those two values. Between 5.1 and 7.5, between 5.1 and 7.5, that's half the range between 5.1 and 9.9. So we're going to take our 95 and divide that in half. So that would be 47.5% of the data. Larger than 9.9. There's a few different ways you can figure that out. We know that between 5.1 and 9.9 is 95% of the data, and there is 100% of the data total. So that would leave us with 5%, and we want half of that. So that would be 2.5%. Since we're only dealing with the half that's above 9.9. Or we did break all of these down into their individual percentages before. We said 7.5 was the halfway point, so 50% of the data is below and 50% of the data is above. This was 34% on both sides. This was 13.5% on both sides. This was 2.35% on both sides. And then this was 0.15, I believe. So we could just add those two values together. So 2.35 plus 0.15. And there's a few other ways you could figure it out, but this also works. Z-score was a formula that I gave you. That was the z-score is equal to the data point minus the mean over the standard deviation. So in this case, our data point is 9.9, our mean is 7.5, and our standard deviation is 1.2. So 9.9 minus 7.5 is 2.4 over 1.2, which is 2. So your z-score is 2. We're going to do the same process for letter E. So we have a baby that weighs 6.3, that's your data point, minus your mean over your standard deviation. We're going to get a negative this time because we're underneath our mean. 6.3 is less than our mean. So 6.3 minus our mean that's negative 1.2 over 1.2. So we have a z-score of negative 1. And then letter F is asking us to find our data point given a z-score of 3. So our z value is 3. We don't know our data point. Our mean is still 7.5 and our standard deviation is still 1.2. We want to solve for our data point, our x value. We need to undo all of those numbers. So I would start by multiplying by 1.2 on both sides. This is going to give you 1.2 times 3 is 3.6. And then we need to add 7.5 to both sides. So that's going to give you a data point, or a baby's weight, of 11.1. Which makes sense, because that plus 3 means 3 standard deviations above the mean. And guess what? 3 standard deviations above the mean is 11.1. Okay, so letter A and letter B are from something called change of base. And I brought that up to a couple of the classes, but I don't think I said that to everybody. It's actually a standard that's part of the California State Standards, but not the Common Core Standards, so it's not tested on the state exam. But it is part of the content standards, so they put it on the final because of that. But yeah, it's kind of ridiculous. So change of base just allows you to change things to base 10, or actually any base you want. Base 10 is the best for using calculators. But basically, whatever base that you're coming from, you're going to put that on the bottom. So in this case, we want a base of 5 because 5 is on the bottom. So using the change of base, this would be equivalent to log base 5 of 25. And then you think about that as an exponential. 5 to what power gives you 25? 5 to the power of 2 gives you 25. So our answer is 2. And this one, 27 is on the bottom, so 27 becomes your base. So log base 27 of 3. And again, you think about this as an exponential. 27 to what power gives you 3? Well, that would be a fractional power. That would be to the 1/3 power. Another way you can think about this is 3 to what power gives you 27. Your answer better be 3. 3 to the 3rd power gives you 27. Just make it a fraction because you're thinking about it in the opposite way. So again, you're just thinking about this as 4 to what power gives you 64. Your answer is 3. 4 to what power gives you 2? Your answer is 1/2. If you take the square root of 4, you get 2. That's the 1/2 power. Or again, you can think about it in the opposite way. 2 to what power gives you 4? Your answer is 2. You make it a fraction because you're thinking about it in the opposite way. And then we can use power rule here, so it's 4 log A of A. Anytime you have the same base, it's going to be 1. So log base 2 of 2 is 1. Log base 3 of 3 is 1. Log base 4 of 4 is 1. Log base 100 of 100 is 1. So log base A of A is 1. So your answer is 4. Or you can think about it as the way that logs are the exponent. Our exponent is 4, so that's our answer, since we have the same base here. So again, log base a number of the same number is 1. Okay, so we have y is equal to x squared minus 6. Remember, when we are doing inverses, we are switching inputs and outputs. So if I switch my inputs and my outputs, I get this equation, and I just need to solve this equation for y in order to create the inverse function. So if I'm solving for y, my first step is to add 6 to both sides, and then I want to take the square root. So whenever I take the square root of something, there is a positive and a negative answer. The restriction here is that I can't have both a positive answer and a negative answer at the same time, because that doesn't pass the vertical line test. So usually we only say it's the positive square root of x plus 6. Number 36 is really simple. If you remember the area formula for triangles AB, 1/2 AB sine C, and you're just plugging in your values now. So 8.4, 15.2, sine 55. That's one way to do it. Another way to do it is to draw your auxiliary line, and you can use A equals 1/2 base times height, since it's a triangle. Use regular SOHCAHTOA, regular sine cosine tangent, for this right triangle to find the height. And then plug in your base of 15.2. So really doesn't matter which method you use. Whatever is going to allow you to remember how to do this on the test works. And all you need to do to know if you're doing this correctly is get an answer of 52.3 feet squared. So as long as you got 52.3 feet squared on this problem, you know that you did it correctly. The method doesn't matter so much. Whatever is going to stick to your memory so that you can use that on the test. For number 37, we really just want to find the maximum and minimum values. So we would have a minimum here, maximum here, minimum here, maximum here. So we have maximums at -1 and 2, and for 5, so your maximum values are 2 and 5. You have minimums at -3, -2, and let's see, 2, -6. So you have minimum values at -2 and -6. So your highest values are 2 and 5. Your lowest values are -2 and -6. And that's it for regular. So if you're in regular, you can stop listening now and just review all that stuff that you previously watched and worked through. If you're enhanced, I'm not going to fill in this unit circle for you. You just need to make sure you have the unit circle memorized. Go look it up. How can you use Pythagorean theorem and relate it to the unit circle? Well, remember we have different triangles that we're actually looking at on the unit circle. This is a radius of 1, so that is your hypotenuse on these right triangles. And then at different angles, like at 30 degrees, this is a special right triangle, so you know this is half, so then you can do 1/2 squared plus your x squared is equal to 1 squared and solve for x that way. And apply Pythagorean theorem to the unit circle that way. For number 40, you're pretty much just doing more composition practice. So you're plugging in one function's output into another function's input. So we're going to plug 3 into g first. So g of 3 is 3 squared minus 1, so 9 minus 1, so 8. And then plug that value into f. So 8 cubed minus 8 squared plus 8. So 512 minus 64 plus 8 gives you 456. So this time we're going to plug 3 into f first, and then plug our answer into g. Again, you guys can plug all of these in at one time. You don't have to plug them in individually. But there's not a ton of room on this problem, so I'm just going to do it this way. So that would be 27 minus 9 plus 3. It's 27 minus 6 is 21. And then plug that answer into G. And then this says plug 2 into F, add 1 to the answer, and then plug that answer into G. So plug 2 into F, gives me 8 minus 4 plus 2. So 4 plus 2, that would give me 6. Then it says add 1, gives me 7. So now I take that and plug that into G. So G of 7. So 48 is your final answer there. And then for 41, you need to remember that log base E is what ln means. And remember, E is just a number, like pi is 3.14, and that goes on forever. E is Euler's number, it's 2.718, blah, 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 it goes on forever. So you just need to remember that ln is just a type of log. The inverse of a log is an exponential. So if you're looking at ln, you need to use an exponential. If you're looking at E, you need to use a log to undo and solve for x. So I'm looking at ln, I need to use an exponential. I'll use exponential base E. That cancels, so you get 2x plus 1 is equal to e to the pi plus 1. That's all an exponent. Pi plus 1 is your exponent. And then we're solving for x. So you would now subtract 1 from both sides. That 1 is not part of the exponent, so we just need to write minus 1. And then we need to divide by 2. So this becomes your answer. You can plug that into your calculator if you need to. I don't think these questions are actually solved out using a calculator on the exam. I think they're left like what you see here. So again, for letter B, I see a log, so I need to use an exponential to get rid of it. So I have 2x is equal to e to the pi plus 2. All of that is an exponent. And then we need to divide both sides by 2, so your answer is e to the negative pi plus 2 all over 2. And again, I think they leave it like that on your test. For letter C, this is an exponential, so I need to use a log to solve, and it needs to be log base E, so I use ln. Natural logs and exponentials cancel. So that leaves me with 7x minus pi on that side. I'm solving for x, so I need to add pi to both sides. And then I need to divide by 7. So your final answer looks like natural log of 2 plus pi. Ooh, that's really bad. Over 7. So all of that is your answer. And then I have the same problem in letter D. I need to take the natural log of both sides. Since it's an exponential form, the inverse is a log. Natural log and the base of e cancel. So you're left with pi x equals natural log of 2. Divide by pi. So your answer is natural log of 2 over pi. There's your answer. Good luck studying for those final exams.